Good morning, everybody. As a part of basic civil engineering subject, we are going for the third lesson, that is angular measurement. And earlier we have done two lessons. That is, one is objectives of surveying, and second one is linear measurements or horizontal measurements. We studied in detail about that one. The next topic is angular measurement. This can be done by using the compass surveying. Introduction. Chain surveying can be used when the area to be surveyed is comparatively small and is fairly flat. But when the area is large, having undulations and crowded with many details, then triangulation, which is a principle of chain surveying, is not possible. In such an area, the method of surveying is used. The principle of compass surveying. The principle of compass surveying is traversing. Earlier, principle of chain surveying is triangulation, which involves a series of connected lines. The magnetic bearing of the lines are measured by prismatic compass. With magnetic bearing is measured by using the north direction. With reference to the north direction, the angle measured is known as magnetic bearing. Compass surveying is recommended when the area is large, undulating, and crowded with many details. And compass surveying is not recommended for areas where local attraction is suspected. Here, what is the meaning of local attraction is having magnetic substances like steel structures, iron ore deposits, electrical cables, and so on. At that locations, compass surveying is not suitable because the needle in the compass may be attracted by the magnetic substances. Next, what is meant by traversing? In a traversing, the framework consists of connected lines. The length are measured by a chain or a tape, and the direction measured by angle measuring instrument. As per the principle, second principle of surveying, the second principle states that a new point can be located with reference to two known points by taking either linear measurement or by taking angular measurement or a combination of both. So at here, in the case of a compass surveying, the traversing is done by using the chain, the distances are measured, and the direction is measured by using the compass. Hence, compass surveying, direction of survey lines are determined with a compass, and the length of the lines are measured with a tape or a chain. This process is known as compass traversing. Next, compass. A compass is a small instrument essentially consisting of a graduated circle and a line of sight. The compass cannot measure angles between two lines directly, but can measure angle of a line with reference to magnetic meridian at the instrument station point. Is called the magnetic bearing of a line. That means directly we cannot measure the angle, but we can take the measurements with reference to the north direction, that is magnetic meridian. The direction of the line is measured. By knowing the direction of that line, we can able to calculate the bearing of the line. From the bearing of the line, we can able to establish the angles. Now we'll see what are the types of compasses used. There are two types of compasses generally used. They are as follows. One is the prismatic compass. Second one is the surveyor's compass. First, we will see the prismatic compass. So this is the figure of the prismatic compass. So it shows so many parts. So many parts are there. About 15 parts are there in the instrument. So essentially, it consists of a compass box. Circular box is there, having a diameter from 8 to 12 centimeters in diameter, and it consists of a center pin point is provided at the center. It is called pivot. Over the pivot, there is a graduated circle is provided. Graduated ring, we will call it as a graduated ring, generally made up of a aluminum one, and printed with the printed, the readings are printed in inverted. That means when you looking through the IVN prism, the reading will be visible. That is the concept right here. So the readings are inverted. The readings are inverted and ascending in the clockwise manner. The readings are marked in the ascending in the clockwise manner. That is 0 to 360 degrees. The complete reading is provided 0 to 360 degrees. Next, this box is covered with a glass cover. Over the this graduated ring, a glass cover is provided to protect the ring as well as the needle. It is provided, and north direction is marked at somewhere, because below this horizontal bar on the graduated ring, below this one, the magnetic needle is provided. The magnetic needle is provided below this one, and whenever if you want to lift the this graduated ring away from the pivot, that is center point, then a hinge is provided, a lifting pin is provided. With the lifting, by pressing this lifting pin, lifting lever operates, and this graduated ring is attached to the glass cover, which is provided over the surface. And on one end, eyepiece is provided. The eyepiece consists of a prism. Built in inside prism is provided. The prism is covered with a aluminum or brass casing, and is provided with a eye slit and eye hole, and which can be adjustable to the eyesight. So a focusing stud is provided. A focusing stud is provided, so that by adjusting this focusing stud, the location of the prism can be upward or lowered, so that when you are looking through the eye hole, the reading will be clearly visible. Based on the your eyesight, this has adjustment should be done. And next, it is provided with a sunglasses, so that in case of a bright sunny days, or whenever you are looking through the prism, through the eye slit to a luminous objects, these glasses will be used, either sun or luminous glasses. For that locations, you have to look through the sunglasses. And on the other hand, an object is provided. At here, in the object when a horsehair is provided, and a mirror is adjustable mirror is provided, and this entire setup is hinged at the bottom. Both in the case of a prism will also be hinged at the other location. Now the line of sight is established by eye slit and the horsehair and its continuation. So for observing the reading, we have to look through the eye hole, and the coincidency is horsehair, which is reflected on the bottom of the ring. So by that, observation will be made in the prismatic compass. As prism is used for reading the readings over the graduated ring, it is called a prismatic compass. These are the elements of prismatic compass. Briefly, cylindrical metal box, already we have discussed. Next one is pivot. Pivot is provided at the center of the compass and supports freely suspended magnetic needle over it, lifting pin and lifting lever, so that to avoid the wear and tear of the pivot, the lifting lever and lifting pin is provided, so that the magnetic needle may be lifted from the magnetic needle, and graduated ring may be lifted from the pivot to the glass. Magnetic needle, the magnetic needle is attached at the bottom of the graduated ring in the and graduated circular ring, generally made up of aluminum. 0 to 360 degrees is marked in the clockwise direction, and the magnetic needle is attached to this graduated ring. And prism is used to read gradations on ring and to take exact reading by compass. It is placed exactly opposite to object vane. The prism hole is protected by prism cap to protect it from the dust and moisture. Other components are object vane. Already we have discussed object vane is diametrically opposite to the prism and eye vane. The object vane is carrying a horsehair or black thin wire to sight the objects in line with eyesight. And eye vane is a fine slit provided with the eye hole at bottom to bisect the object from slit. Glass cover, it covers the instrument box from the top such that needle and graduated ring is seen from the top. Next is sunglasses. These are used to when some luminous objects are to be bisected. Reflecting mirror. Reflecting mirror. It is used to get the image of an object located above or below the instrument level while bisecting. It is placed on the object vane. And spring break or break pin. To dampen the oscillations of the needle, that is graduated ring, before taking the reading and to bring it to the rest quickly, the light spring brake attached to the box is brought in contact with the edge of the ring by gently pressing inward the brake pin. Now we'll study about the temporary adjustments of a prismatic compass. The following procedure should be adapted after fixing the prismatic compass on the tripod for measuring the bearing of a line. First process is centering. Centering is the operation in which compass is kept exactly over the station from where the bearing is to be determined. The centering is checked by dropping a small pebble from the underside of the compass or a plumb bob by using a plumb bob. If the pebble falls on the top of the peg, then the centering is correct. If not, then the centering is corrected by adjusting the legs of the tripod. And next operation is leveling. Leveling of the compass is done with the aim to freely swing the graduated circular ring of the prismatic compass. The ball and socket arrangement on the tripod will help to achieve the proper level of the compass. This can be checked by rolling round pencil on glass cover. And the third adjustment is the prism is moved up or down in its slide till the gradations on the aluminum ring are seen clear, sharp and perfect focus. The position of the prism will depend upon the vision of the observer. Next step is observing the bearing of line. Consider a line AB of which the magnetic bearing is to be taken. By fixing the ranging rod at station B, we get the magnetic bearing of the needle with respect to the north pole. The enlarged portion gives actual pattern of the gradations marked on the ring. So the readings are marked like this one. On the north of the graduated ring, 180 degrees is marked. On the north of the graduated ring, 180 degrees is marked. On the east of it, 270 degrees is marked, and on the west of it, 90 degrees is marked. And on the south of it, south of the graduated ring, 0 is marked. So whenever north is showing, then 0 will be visible under the eyesight, prism, through the prism. Prism is provided at here, object vane is at here. So on the object vane side, north is marked generally. Here, object is ranging rod at B and station point is A. Station is said. This is the line of sight. This line is the line of sight passing through the center of the station. So you will obtain a reading from south to this one clockwise. The reading is enlarging in the clockwise direction. So hence the reading south is marked with 0. So your line of sight, that means IVN prism is provided here. So you will obtain the bearing of the line with reference to the north direction. Next step. Next type of instrument is called a surveyor's compass. It is similar to a prismatic compass, except that it has a only plain eye slit instead of a eye slit with prism and eye hole. Direct reading can be obtained at here. This compass is having pointed needle in place of a broad form needle, as in the case of a prismatic compass. This following figure shows the surveyor's compass, which is similar to this one, but however a little bit changes the surveyor's compass. Now we'll see how the bearings are measured by using the compass. The bearing of a line in the horizontal is the horizontal angle which it makes with a reference line. Depending upon the meridian, there are 4 types of bearings. They are as follows. The first one is true bearing. The true bearing of a line is the horizontal angle between the true meridian and the survey line. The true bearing is measured from the true north in the clockwise direction. Next variety of bearing is magnetic bearing. The magnetic bearing of a line is the horizontal angle which the line makes with magnetic north. Next is grid bearing. The grid bearing of a line is the horizontal angle which the line makes with the grid meridian. And last one is arbitrary bearing. The arbitrary bearing of a line is the horizontal angle which the line makes with the arbitrary meridian. Working of surveyor's compass: centering, leveling, observing the bearing of a line. First 2 observations are same as prismatic compass, but the third observation differs from that one. In this compass, the reading is taken from the top of glass and under the tip of north end of the magnetic needle directly. No prism is provided at here. True north, here it shows the true north direction, true north, and magnetic needle may establish slightly deviating from the true north direction. That shows the magnetic north at here. AB is the line whose bearings has to be measured. AB is the line whose bearing has to be measured. If with reference to magnetic north, if you have measured the bearing, that is called magnetic bearing. And observe it here, magnetic bearing. When you make a bearing with reference to the true north, the bearing is known as true bearing of the line AB. And this is called magnetic meridian, and this is called true meridian. The line established passing through the station point A is called true meridian, meeting the true north and true south poles passing through the station A is called true meridian. And which may be also established with the magnetic needle, it is called magnetic meridian. Sometimes a little bit error may be there between the true meridian and the magnetic meridian. That we will study later. Next is designation of bearings. The bearings are designated in the following 2 systems. One is whole circle bearing system. Second one is quadrantal bearing system. By using the prismatic compass, The bearing of a line is measured with respect to magnetic meridian in clockwise direction is called magnetic bearing, and its value varies from 0 to 360 degrees. So this can be established by using the prismatic compass. And the quadrant start from the north on progress in the clockwise direction, as the first quadrant is 0 to 90 degrees in the clockwise direction, and second quadrant will be 90 to 180, and the third quadrant will be 180 to 70, and up to 360 degrees is the fourth one. Now here I had given an example. True north, with reference to north, we are measured a bearing of OA, bearing of OA, which is lying in the first quadrant, is having a angle bearing of 70 degrees. Coming to the second point, that is lying in the southeast quadrant, that is OB, having a bearing of 135 degrees, lying in the second quadrant, whereas the third line OC, lying in the third quadrant, maybe in the range of 180 to 270, that is 265 degrees, 36 minutes and 20 seconds, may be measured more exactly by using the other instrument. And fourth quadrant, that is OD, lying in the fourth quadrant, that is northwest quadrant, bearing is 328 degrees. This is an only example. So if the line is lying in the first quadrant, it may range of the value will be 0 to 90 degrees. If it is lying in the second quadrant, its value is 90 to 180, and in the third quadrant it may be 180 to 270, and in the fourth quadrant it may be 270 to 360 degrees. And second variety of system is quadrantal bearing system. In this system, the bearing of survey lines are measured with respect to north line or south line, whichever is nearest to the given survey line, and either in clockwise direction or in anti-clockwise direction. So these measurements can be made by using the surveyor's compass. Prismatic compass is not suitable at here. At here we have to use the surveyor's compass. In this one, quadrantal bearing example figure is given at here. So in the first quadrant, you can see that with reference to north, the bearing is measured in clockwise direction, lying in the first quadrant. OA line is lying in the first quadrant, 27 degrees. And the second quadrant, if the line is lying in the second quadrant, with reference to south, in anti-clockwise direction, we have to make the reading, that is 77 degrees, for example, OB. Third line is lying in the third quadrant, that is southwest quadrant. In this one, reference is south and moving in the clockwise direction. The reading is increasing in the clockwise direction, whereas in the last line is lying in the fourth quadrant. The reference is north and in anti-clockwise direction. Measurement is taken in anti-clockwise direction towards west, 20 degrees. So in the case of a quadrantal bearing system, the reading will be written like this one. For example, south is the reference axis, east towards east moving. So 77 degrees east, south 77 degrees east. So quadrant will be mentioned at here and the bearings are given at here in between the quadrants, south to east. So direction is mentioned at here, south to east. Next one. Reduced bearing. When the whole circle bearing is converted to quadrantal bearing, it is termed as reduced bearing. Thus, reduced bearing is similar to quadrantal bearing. Its value lies between 0 to 90 degrees only, but the quadrant should be mentioned for proper designation. The following table should be recommended for conversion of whole circle bearing to reduced bearing. So when whole circle bearing of a line lying between the 0 to 90 degrees, Then quadrant in which it lies is first quadrant. Then reduced bearing equal to whole circle bearing, and quadrantal bearing will be having a northeast quadrant. And when the whole circle bearing of a line lying 90 to 180 degrees, it is in a second quadrant, and reduced bearing can be obtained, which is equal to 180 degrees minus whole circle bearing. Simple conversion, 180 minus whole circle bearing. The quadrant has to mention is southeast. And when the bearing of whole circle bearing of the line is lying 180 to 270 degrees, then quadrant in which it lies is third quadrant. Reduced bearing is given by whole circle bearing minus 180 degrees. And the quadrant should be mentioned is southwest, south theta west, like that one. When the range of the whole circle bearing is 270 to 360 degrees, it is lying in the fourth quadrant. Reduced bearing can be equal to 360 degrees minus whole circle bearing, and the quadrant mentioned is northwest. The bearing of a line measured in the forward direction. Next type of bearing is the bearing of a line measured in the forward direction of a survey line is called the fore bearing of that line. Fore and back bearings. The bearing of a line measured in the direction backward to the direction of progress of survey is called the back bearing of the line. Example figure here. Let us say A, B are the two stations. From A, B we are moving. If the bearing is measured from A to B, that is theta 1. Theta 1 is the fore bearing of line AB. Fore bearing of line AB. Whereas if from the B, instrument is over station B and the bearing is taken to A, then that is theta 2 is known as back bearing of line AB. It is fore bearing, back bearing. When you are observing from the succeeding station, it is a back bearing. So at here again, fore bearing of line AB equal to theta 1 from A to B, where back bearing of AB is theta 2 from B to A we are observed. So while taking this one, we have to follow following point should be remembered. That is in the whole circle bearing system, the difference between the fore bearing and back bearing should be exactly 180 degrees. Remember the following relation: back bearing equal to fore bearing plus or minus 180 degrees. Plus sign is applied when fore bearing is less than 180 degrees. Minus sign is applied when back bearing is greater than 180 degrees. And the second point you have to remember is, in the reduced bearing system, the fore and back bearings are numerically equal, but the quadrants are just opposite. That means northeast to southwest, opposite is. For example, southeast to northwest, opposite lines. Next is computation of angles. From the bearings, we have to compute the angles for plotting purpose as well as calculation purposes. Observing the bearing of the lines of a closed traverse, it is possible to calculate the included angles, which can be used for plotting the traverse. At the station where two survey lines meet, two angles are formed, an exterior angle and the interior angle. The interior angles are included angles is generally the smaller angles, that is less than 180 degrees. Observe that one. These are the included angles. You have to compute the included angles for checking the traverse calculations, and for further traverse calculations also these included angles may be useful. Let us say ABCD is a ABCD is a traverse. Example is given here. AB. So to calculate included angle between the two lines taken from same instrument station, that is A. From A we are observing the bearing to E as well as B. AB is this direction and AE is in this direction. We have taken two bearings. One is back bearing of AB, and another one is fore bearing of AE. So included angle can be computed from the back bearing to minus fore bearing. At station A, fore bearing of AB and back bearing of EB were measured. The difference of the two bearings gives the interior angle. From the picture it is clear. The difference is angle A. Angle A equal to FB of AB minus VB of EA. Similarly, coming to the another example, here fore bearing of AB, back bearing of, and here we will obtain a, if the follow the same rule, we will obtain a, at station B, fore bearing of BB, fore bearing of BB of AB were measured. The difference of the two bearings will give exterior angle. We will get the angle B is exterior. So to get the interior angle, you have to deduct it from the 360 degrees. 360 minus exterior angle will give the interior angle. Exterior angle B is obtained. BB of AB minus FB of BC. So it is greater than 180 degrees. Then to obtain the interior angle, you have to deduct it from the 360 degrees. Thank you.